For this lab, we will calibrate the pH meter between 2 points of 4 and 7 on the pH scale. To begin the process of calibrating the probe, you must gently wash the probe and dry it on a paper towel from the buffer solution it is originally in. Then you can begin the process by placing the probe in a pH buffer solution of exactly 7 and calibrating the probe value at 7.0. Then, after washing the probe again in distilled water, you can then place it in your second value buffer solution with a pH of 4. Then, once the meter has stabilized, you can record the pH value of 4.0 into the LabQuest. Once you have completed that process, you are done calibrating your probe. To be sure, if you would like, you can replace your probe back in the 7 buffer solution and see if the value of the pH meter reads as 7. We tested various known solutions for their respective unknown pH levels. For each solution, the process was the same, with a gentle rinsing and dabbing of the pH meter with distilled water, and then the probe being placed directly into the solution. For certain solutions, we did have to wait a bit for the pH to stabilize, so for convenience sake, the process is sped up quite a bit. Certain solutions had pH values that were on ends of the spectrum, meaning they were either strong acids or strong bases. Other solutions remained more in the center of around 4 to 9, meaning they were weaker acids and weaker bases. In case you don't know the difference between a strong acid/base versus a weak acid/base, we will now explain.
The difference between a weak and strong acid is how it dissociates in a solution. A strong acid dissociates completely into 2 separate ions, which means it is a one-way reaction. A weak acid only dissociates partially, which means these reactions can go 2 ways. The strength of the acid is what determines which way the reaction will be favored, which also affects the equilibrium. Whichever side the strong acid is on will be favored. To make this differ, you can add different strength acids and bases to each side of the reaction, which will affect the equilibrium.
Obtaining the pH of the buffer solution was relatively easy. After preparing the solution, we simply washed the probe with distilled water and placed it into the buffer solution and waited for the meter to stabilize.
A buffer is a solution that can resist significant pH change upon the addition of an acidic or basic component. Buffer solutions have a working pH range and capacity which dictate how much acid or base can be neutralized before pH changes, and the amount by which it will change.
Buffers work by reacting with any added acid or base to control the pH. It's able to neutralize small amounts of added acid or base, thus keeping the pH of the solution relatively stable. This is important for processes and/or reactions which require specific and stable pH ranges.
Cleaning and storing the pH meter is a very simple process. You must first unplug the LabQuest, then gently wash the meter with distilled water, shake it out a bit, and then place the probe back into its original solution/container. Then, after wrapping the wires that are connected to the probe and grabbing the LabQuest, you then place them back correctly into the cart in their respective places. After that, you're done for lab. Here are our notes for the lab work done, and we were sure to clean up our lab table exactly as we had found it before. Thanks for watching.